Hello team. I've had a few questions about how we solve angled vectors on the vectors and phases quiz, and in particular around question 10. So I just thought I'd record a quick video and go through in particular that solving for an angled vector. So we know that if we have vectors that are going in the same direction or in opposite directions to each other, those are pretty easy to solve, right? If I have a vector that's going in this direction and it has a value of 4, and then I have another vector going in the same direction with a value of 2, I can just add those together and it gives me one vector with a value of 6. That's simple enough. If I were to have a vector running in this direction, so right to left as I'm looking at it, and another vector running left to right, and I needed to add those together. If this is value 6 and this is value 4, then I'm going to subtract one from the other. So this one is 4, this one is 6, so my final result will be a vector going in this direction with a value of 2. Again, simple enough. If we have a vector that's running at a 90-degree angle to or if we have two vectors that are running at 90-degree angles to each other, then we use Pythagoras theorem to give us the result. So if I have a vector running this way and a vector running this way with a 90-degree angle between them, I can use Pythagoras' theorem to solve for that side, and that's going to give me the size and direction of the new vector. So that the new vector will be coming here, but the angle will be the same, and the length will be the hypotenuse of that triangle. So again, that's fairly simple. I think everybody has got a fairly good idea of that. Now, what happens when I have two vectors that are at an angle to each other that is something other than 90 degrees? So let's say that angle is 60 degrees, for example. This is where we seem to be struggling. So if we just look at this vector individually. Now we know, as I just said, that if I have two vectors that are at 90 degrees to each other, then I know that the hypotenuse of that triangle, if I draw in the hypotenuse, that will give me the result. So that plus that equals that. Again, this plus this equals this. So what we're saying there is these two sides here that are at 90 degrees to each other are the same. The addition of those two is the same as this side here. Just like if I said 2 plus 2 is 5, then I could also say 5 is, what did I say, 2 plus 2 is 5? Let me try again. 2 plus 3 is 5. Then I could also say 5 is 2 plus 3. So if I'm saying that this side plus this side equals this side, then I could equally say that this equals this and this, right? So I could divide up that side there into this, and that is the same as saying this plus this equals this. This is equal to this plus this. Okay, I hope that makes sense. So now for the magic. If I have this vector here and it was at 60 degrees to horizontal, well, I could draw a triangle, a 90-degree triangle with this line as the hypotenuse, and just like I could say that this plus this equals this, if I already have this line, then I can break that line down into this and this. Why would I want to do that? Well, solving vectors that are moving on the same plane, either in the same direction to each other or opposite to each other, is easy. Whether they're vertical or horizontal, I can easily add those things together. If I have vectors that are 90 degrees to each other, so one horizontal and one vertical, that's a little bit more challenging. I've got to use Pythagoras theorem. But again, it's simple enough. We can do that. Adding that angled vector is quite difficult. So what I want to do is change that angled vector into two other vectors, one horizontal and one vertical. no matter how many angled lines I have, if I break each of those angled lines into a horizontal and a vertical component, as we call it, then I can take all my horizontal and vertical components and add them together individually, and then I get the answer, the final answer for my problem. So let's have a look at how we're going to do that. So I'm going to draw a triangle. So let's say we start with 60 degrees there, and let's say the length of this vector is 5, as I said. So if our problem tells us we've got a vector of value of 5 at 60 degrees to horizontal, how do I add that to another vector? Well, I'm going to break it into a horizontal and a vertical component, and we do that using trigonometry. So we're going to use our saw, car, tower. So what I have here then is a right angled triangle with an angle and the hypotenuse. And I need to find the value of the other two sides. So I'm going to start with, let's say want to find the value of this side here. So that is the opposite side because it's opposite to the angle. So I have the hypotenuse then, I have the angle, and I want to work out the opposite. So opposite and hypotenuse. So I'm going to use SOH. Sine of the angle is equal to opposite over hypotenuse. Then I want to find the value of opposite. So I'm going to feed in the two values that I have here, 60 degrees. So we can say sine of 60, because that's the size of our angle, is equal to opposite. That's the value I'm trying to find here. That's the opposite over the hypotenuse, which is 5. So sine 60 equals O divided by 5. Let me just get my calculator and I'll work that out. So I just put it into my calculator. Well, actually, I'm going to transpose that. I need to get rid of this 5. I just want to see what the O is on this side. So it'll be 5 times sine 60 equals O. So I put into my calculator. Sine 60 times 5. And that says 4.33. There you have it there. Sine 60 times 5 equals 4.33. So that means the value of my opposite side here, 4.33. Cool. Now I need to find the value of the third side, right? And then I have my whole triangle. So I use Pythagoras' theory for that. I have my hypotenuse, I have that side, I need to work out this side. So it's going to be square root of b squared equals, or square root of b squared is b. I'm calling this side b, this side a, and this side c. So b equals the square root of c squared minus a squared, which means b equals square root of c squared, 5 squared, minus a squared, 4.33 squared. And I'm just going to put it into my calculator like that with brackets. Square root of 5 squared minus 4.33 squared. I put brackets around that, and that gives me a value of 2.5. Square root of 5 squared minus 4.33 squared equals 2.5. So that's the value of my bottom side here, 2.5. So now what I'm saying is that vector there We've gotten rid of that vector there, and we've turned it into these two vectors here. So I can erase all of that. And I just use these two numbers instead. So if my original question then was add a vector of 5 horizontal to a vector of 5 at 60 degrees, we just worked out the horizontal and vertical components of that angled vector. So now I can just add these two to the bottom one, 5. So what will I have? I will have that's the direction of my vectors there. So that means I've got one vector, that's 5. That's this original one here. Now, I'm not going to worry about that original one there. I've turned that into two different vectors, one of 2.5 and one of 4.3. So I'm going to add on the 2.5 here, because that's on the same direction as the 5, which gives me a bottom side of 7.5. And then I've worked out I've got a horizontal vector of 4.33. I worked that out by breaking this vector here into a horizontal and a vertical component. So now I just use Pythagoras, get a different color pen, to find out the hypotenuse of that triangle, and that's the answer. So I'm going to use the same formula. I'm going to go square root of 7.5 squared plus square root of 4.33 squared should be equal to this side here. And that gives me a value of 8.66. There we go there. Square root of 7.5 squared plus 4.33 squared is 8.66. That side is 8.66. So then our answer is, if I have a vector, a horizontal vector of 5 plus an angled vector of 5 at 60 degrees, then my answer is 8.66. And if I wanted to work out the angle, this angle here, it's going to be whatever that angle is there. I could work that out using trigonometry. I don't think you're required to do that in the test, but if I wanted to, I would just work out that angle there, and then that would be that's what that angle there is. If we have a question like question 10 in your book, which has multiple angled vectors, it requires more calculations, but it's essentially the same thing. There's no problem. So if I had a vector going this way, one going this way, and one going this way, I work out the horizontal and vertical components of this vector first. Then I work out the horizontal and vertical components of this vector, and then I add them all together. Then I should have two verticals because I've got one here, one here. I add those together. I should have 3 horizontals, one there and one there. And I add those 3 together, and then I make a triangle from the result, and that will give me my final answer. Okay. Only one other thing you need to be aware of, whether those horizontal and vertical vectors are positive or negative. A horizontal vector running this way is positive. When I work out the horizontal component of this section, that horizontal component there will be negative because it's running in the opposite direction to this one. So when I add them together, I'm going to subtract that one from that one. The horizontal component of this vector, that horizontal component there will be positive because it's running in the same direction as this one. So I'm going to have 2 positive horizontal vectors and 1 negative one. With my vertical vectors, because they're all going upwards, they're going to be both positive. If I had in my question a line running this way, then my horizontal component is positive it's going this way, but my vertical component will be negative. Even if I had this many, if I had 1, 2, 3, 4 vectors, to add them together, same process. Break each of the angled vectors into horizontal and vertical components, add all the horizontal and vertical components. That should give you one horizontal line, one vertical line, and I work out the value of the hypotenuse, and that's my answer. Okay, I think that should give you all the information that you need. If you watch this video and you're still struggling, shoot me a text and I'll see if I can help you out.